Hello everyone. This is Rashid Kibriya from Fixed Research, University of Florida. In this demonstration, I will talk about the version of the FSMx-Ultra tool which can analyze hierarchical netlist. I have developed a different version of FSMx-Ultra which is dedicated to analyze the hierarchical version of it. It is nothing but a more extension of the previous version. That means the version which can analyze a netlist with no hierarchy. That means basically a flattened gate level netlist. In this demo, I will try to analyze the hierarchical gate level netlist of the memory controller core. This memory controller core was taken from opencourse.org. It is a good example of a very complex IP core. I have changed the state encoding there. There were total 66 states. So I used the binary state encoding scheme. As a result, the FSM was encoded using a 7-bit vector. Here is the FSM extraction report, which I obtained using my RTL FSMS tool. And it is basically showing us the states present in the RTL design, the state variable, and also the encoding bit length, their type, that means the state encoding style, and some other information. This ASIC gate level netlist of memory control IP is hierarchical because if you look here, this design has so many modules. These modules basically means each of the blocks were synthesized individually, and finally they were integrated by the synthesis tool. Here we see another module, and similarly, if you scroll through it, there are multiple modules here, and finally you will get into the top level module. Here is another module, and finally at the bottom there is the top level module. So this netlist file has hierarchy. It is not a single graph, rather collection of multiple netlist graphs. I will try to analyze this using my FSMx-Ultra HN tool. You can find that tool here inside this folder, and if you write stage mode 777 UI, and then you have to invoke the user interface, and if you write that, it will open up a graphical user interface for you. The first task, I will read the technology library file as before, so I can find it inside memory controller folder. Here library and size 90 nanometer typical library was used during synthesis, and I have basically used Cadence Genus as the synthesizer. So I add the lib file, and then I add the technology library in .b format. And finally, I read this hierarchical gate level netlist, which you can find inside inputs folder. And if I hit open, it will add that. And finally, the RTL FSMX report. So I will now click on the configure FSMX Ultra button, and then hit on extract control FSMX button. And if I click on it, you will see some messages printing up. Here, some error message will be thrown away. You can basically safely ignore that because it is just coming from finding some files here. It is not important. Just you have to wait as long as the analysis is finished. And if you look here, it is very fast. You see the entire netlist is being analyzed, and one after another module is being taken, and finally now this one is the FSM part which has been extracted. You see, it is really so fast. FSMx Ultra supersedes FSMx in all aspects. Here you see the analysis has been already finished. So if we go inside here, we can now hit on the exit button. If we click on exit button, it will basically close this graphical user interface. And if I hit here, now get inside this FSMx Ultra HN folder, and if I reload that, there will a report folder created. And this first name is basically the module name where the FSM was located, and then underscore report. So if we go inside, it will again have these three subfolders. Inside netlist folder, we have the FSM minimum extraction region along with the combinational state transition logic. So the control FSM of this memory controller IP is shown here. It is a very big file because it has lots of gates here. Not only that, this block has also large number of inputs. As a result, FSMx was unable to solve it. It was basically unable to extract the state transition graph as I used exhaustive gate level simulation there. FSMx-Ultra is free from this because FSMx-Ultra utilizes ATPG-based approach. So it is 1,000 times scalable compared to FSMx. And this one is the pure combinational state transition logic now of this memory controller core. And if you select here, you will see there are lots of inputs here. So I now close it, and inside statistics folder, you can find here the report. So if we look here, there is only one control FSM, and this one, it has an 100% FSM probability metric with 487 gates in the FSM minimum extraction region. And of these 487 gates, 7 gates are actually the state flip-flops. So the rest of the other 480 gates actually form the pure combinational state transition logic. Finally, if I want to show you the state transition graph, you can find here inside STG underscore report folder. Here, this gate level STG is shown, and you see it is a very complex. I have obtained the same gate level STG when I tried to analyze the flattened version of it. And here you see this very complex state transition graph. Here are total 128 states. 66 states were present in the RTL abstraction. So the rest of the other states are additional states or unspecified or don't care states. So those were actually identified by FSMx-Ultra perfectly. Not only that, they are state transitions as well. And if I now close this file and go here inside this verbosity file, so it actually provides us the state transition graph with a verbosity. That means for a certain particular state, we have a certain state transition, and then the transition conditions are being reported. So here we see a very long line of input patterns because the pure combinational state transition logic has this number of primary inputs to apply the state transition conditions, and it was actually provided by the ATPG tool automatically. So we can also look for how many conditions are there. So if we go here at the almost at the last page, yeah, there are total 46 conditions for that state transition. And here it is showing us which pattern and in which primary inputs you have to apply those patterns. So here is the present state pins. And from there, we go to the next state pins. And finally, to the all the pins where you have to apply the patterns to get such a state transition. So this clearly shows you that FSMx-Ultra can analyze not only the flattened gate level netlist, but also hierarchical netlist. That was a quick demonstration of FSMx-Ultra ASN. Thanks for hearing.